Hello everybody. I've had a couple of different questions about the what ifs for a series RLC circuit. So I'm just going to take some time and we'll talk about the three different components in this circuit: the resistive load, the inductive load, and the capacitive load, and how changing frequency is going to change some of the properties of some of these loads, which is going to affect how much current is in the circuit, which therefore is going to affect how much power, reactive power, or apparent power is within this circuit. The first one we'll look at is the resistive load. If we remember back what types of things affect the resistance of the circuit, the resistance of the circuit is determined by the material that's being used, the cross-sectional area of the material, the length of that material, and its temperature. So the material being is it copper, aluminum, is it iron? Like what type of conductor are we actually using? What size is that conductor? Is it a 250 kcml conductor or is it a 14 gauge conductor? How long is it? Is it 100 meters? Is it 500 meters? And then its temperature. So if you look, if I want to say, okay, how does frequency affect the resistance of a load? It doesn't. These are the four things that affect the resistance of a conductor. Copper versus aluminum. Okay, its resistivity, its area, its cross-sectional area, the size of that conductor, how long is it, and the temperature. The bigger the wire, the bigger the conductor, the lower the resistance. The longer the conductor, the higher the resistance. If I increase the temperature on that conductor, depending on its temperature coefficient, quite likely I'm going to increase its temperature. So frequency isn't going to change the resistance of my circuit. Could it change? Is it going to change the inductive and capacitive? We'll definitely look at that. The resistive part of my circuit could be a couple of things. It could be just the physical properties of the wire. Did I use copper or aluminum? The resistive load could be, is it a baseboard heater or is it an incandescent lamp? Doesn't matter. If it's the physical property resistance within my circuit, frequency is not going to change it. Okay? The inductive load, however, the easiest way to envision this is with the formula for inductive reactance, which is 2 pi FL. So the complete rotations within a cycle, the frequency that rotation is taking place, and its inductive property. This is a linear formula. So if I increase my frequency, I will increase my inductive reactance. So if I increase my inductive reactance, that's an ohmic value. If I increase my opposition, I am going to limit current. The other thing can be said for a capacitive load. Capacitive reactance is XC, which is 1 over 2 pi FC. This is how I affect capacitive reactance. So in this case, we said frequency increased. Well, if I increase the frequency, I will actually decrease my capacitive reactance. And this is proportional. So if I doubled the frequency, I would double the inductive reactance. If I doubled the frequency here, I would actually half the inductive reactance because of the inverse characteristics. So now when we put this all together and we have this complete circuit, I like to look at an impedance diagram for an AC circuit. So we have the resistive component, we have the inductive component, and that relationship is 90 degrees. That's why it's drawn like this. If all this was a coil, so I have the resistive component, the inductive component, this would be the impedance of the coil. So if I increase the frequency, does it change resistance? Nope. This is how I change resistance. Will I change the inductive reactance? Absolutely. I increase the frequency. The vertical part of this diagram would increase. I would therefore increase my impedance. Ohm's law says that the voltage is directly proportional with current. Total opposition is inversely proportional with current. So if I increase my impedance, I will decrease my current. So we can look at the capacitive load. Well, there is no resistive component of my capacitive load, okay? If I had all three of these properties in my circuit, the capacitive reactance, that relationship is still 90 degrees from the resistance. So we increase the frequency, we're actually going to decrease, or if you want to look at this diagram, we are going to shrink this. So it was at that magnitude, now maybe it's half because we doubled the frequency, okay? So my XL would decrease. So this is just the simplest way to envision this. If the only thing in this circuit was a capacitor, if you decrease the opposition, you're going to increase the current. If the only thing in that circuit was a resistive load, if you increase the frequency, you're going to increase its opposition, decrease the current. If the only thing in this circuit is resistance, you can change the frequency, do whatever you want. You're not going to affect the current within that circuit by changing frequency. The next thing I'm going to look at is the question about unity. So that'll be in the next video. I hope this has helped just to give a little bit of clarity. See you in the next one.